Hello everyone. In this video, we'll be talking about Boolean retrieval model in information retrieval. So we will go through its concepts, implementation, and how do we apply it using Python language. So let's move on. So before we go deep in this topic, let's first discuss what is information retrieval. Information retrieval, short for IR, is the science of finding relevant documents from a large concepts collection in response to a user query. Search engines such as Google or Bing uh, or library catalogs and database systems all rely on these IR principles. So when we come to this information retrieval, the main problem back those days where like there are millions of documents. How do we find the right one in effective and a fast manner? So many software engineers came with this idea of building retrieval models that match queries to documents systematically, and thus came the this Boolean model system, which is the simplest and the most foundation retrieval model, and this will be our focus today. So Boolean model laid the foundation for information retrieval in a fast and effective manner. So let's now talk about this Boolean model. So Boolean model, it's actually works on the Boolean logic gates and or and not, and it actually treats each document as a set of keywords and answers queries using classical Boolean logic, just like I told you, and or and not. It's deterministic, that is, document either matches a query or it does not. So when we talk about this Boolean logical operators and or and not, how does it actually performs in a Boolean model for information retrievals? So when we talk about the AND operator, it returns documents containing all query terms. Just like I told you, like if you see this diagram, you can understand is that it finds elements in both sets. And sets it means two different what to say two different databases or two different web pages, anything it can be, or terms, anything. And or it returns documents containing any term, like as I told you, find elements in either set. If it's available in this set, it will be fetched. If available in this set, it will be fetched. And similarly, if we go to the not operator, it will return documents that exclude a specific term. That is, it won't give that particular term, but some other term associated or not related. Moving on, as I told you, for Boolean model to perform efficient information retrieval, we need a proper solid document representation. Before any searching can happen, documents must be pre-processed and stored in a structured way, such as stored as text collections. Raw documents are held as plain strings in a collection. As I told you, and it's not only important in this in Boolean model, it's also very important in other aspects such as data science or other AI-based tasks, such as which is also called data pre-processing. So the raw documents or the text needs to be held or ordered in a plain strings in a collection. And also we need to assign unique IDs to each document, such as each document here receives a numeric identifier, just doc1, doc2, to identify them fast and to not get duplicates or some different documents by mistake. So similarly here we can say, like an example data set example is that a simple corpus is used to demonstrate indexing and retrieval. So like moving on, we can also here we can have this inverted index. So inverted index is a core data structure of the Boolean model. It's basically the idea behind this model. So it maps every unique term in the corpus to the set of document IDs in which the term appears, enabling lightning fast lookups. So if we see this diagram here, so basically first we'll tokenize the documents, like we will ID them in a unique manner so that we can fetch them later without any issues, and build document DMAP. So basically, it's a basically a table or it's a map in which we link the ID and the documents together, and then we store as an inverted index. For example, the term machine might map to doc1 and doc2. But it might be present in both documents, while Python term will be mapped to document 2, 3, and 4. So at each query time, the Boolean operators are applied directly to these sets, which makes the process a whole lot easier. And yeah, Boolean operators. Now we will discuss a lot about these Boolean operators such as and, or, and not, which is used in this model. So let's take an example of a machine and learning. So it returns only documents containing both terms. So let's say this is one document, document two. So it will give this result as one and two. And in OR operators, which is basically union, and here is represented as intersection. It's basically the classical set theory which is used in maths, and it corresponds to this Boolean logic gates also, or Boolean logic operators also. So here or represents returns talks containing either term. So if it presents in documents 1, 2, 3, 4, so it will be fetched and the result will be documents 1, 2, 3, 4. And similarly, exclusion not operator. So if we want an not AI term, so it will return all the docs that do not contain the term, such as 1 and 3. So the before going to the code implementation, understanding how it works using Python language, we must first understand the system flow of this Boolean model. So as I told you before, using this model, we need raw documents which will help us to query results. And the Boolean retrieval pipeline or the workflow follows five major clear stages, such as first, as I told you, it inputs documents, that is, load the raw text corpus, builds index, it uniquely tokenize and maps terms to IDs, followed by the third step, parse query, identify terms and operators, and fourth is we use the logic operations, the Boolean logic operations such as and, or, not on the sets. And at last, we will get results, which is nothing but outputs matching the document IDs. So this is actually how the Boolean model works for the information retrieval. So next onwards, we can now look at the Python implementation. So the Boolean retrieval system can be built concisely in Python using native data structures. Now, when it comes to these kinds of tasks, such as AI tasks, data science, and web scraping and information retrieval, Python is widely used because of its simplest code, uh, and it works very charmingly in large codes or codes of lines, where it becomes much easier to distinguish or to find debugging and all compared to other languages such as Java or C. So it's widely used in these kinds of tasks. So before the some of the key operators or we'll be using is like Python dictionary, which stores each document by its numeric ID. Like I told you, we need to map each document to its unique numeric ID. So we're using that using Python dictionary. And of course, we're using a set-based index. The Python set object powers fast and or a not operation. And of course, we were using a function as a query processor that parses user input and dispatches to the current Boolean handler. So this is the like code for this Boolean retrieval model implication. So here we are considering four documents. You can even think of it four sentences. First sentence goes as data science, machine learning, Python. Second, machine learning, deep learning, AI. Third, Python data analysis, visualization, AI robotics automation system. So here, as I told you, we build an inverted index. We take about this document ID, text in documents, items to search, we split. Basically, we are doing the data pre-processing and to make it easier to apply the Boolean logic operations. And here, as I told you, we are going for the step 2, that is Boolean logic operation. So we start with Boolean logic operator AND. So as I told you, it will give us all the queries with the following terms. So here you can see it by using it like this. In OR, we'll use the find the query with either sets, and in NOT is exclusion. We will find those kinds of sets which are not available, and we then move on to the step 3 query processor. So here we will go with the Boolean search. So we will input a query. So first we will make sure that all the queries are in lowercase and split it accordingly. And if now we are reading the input, if it's and or a not, and we will return accordingly to what the user has input. So example, like here is an AND operator. So Boolean search, machine learning, and add. We'll search like that. So for AND we are searching machine learning and learning. For OR we are searching AI or Python. And for searching not, we are using not AI. Basically the same examples which we saw, we will using the same thing for simplicity purposes. So here we send AND query. So here the original we have given is machine and learning. So if we go and see 1 and 2, yeah, of course it has machine learning and here also machine learning. So machine and learning both are there. So yeah, 1 and 2. And if you observe, it's not present in 3 and 4. So 1 and 2 is the correct answer. And if we compare OR query, which is we have inputted AI or Python. So either of them is present, then it will be selected. So Python is there, here is there Python. So document 1, 2 it has AI, so document 2. 3 also has this Python, so it's all be selected. AI is also there in fourth, so all the fourth will be selected here because we are seeing either of them present and not query. So we should look for statement which does not contain this AI term, and those are only 1 and 3. So see, 1 and 3 doesn't have any AI term here. Here also doesn't have any AI term. So the answer is correct. Like so not query 1 and 3. So this is how we like implement the Boolean retrieval model implementation. At first, we go with the building an inverted index. Then for data processing and stuff, and then we go for this Boolean operations and like and or and not. Then we go for query processing. We use this function to search the query. And then last, we are using some example queries to see how the code performs, like AND operators, OR operators, and not query and all. So coming back to the slide, as I told you, this is the query which we used, AND operator, machine, and learning. So likewise, we can see the result. I have not written the result here because we got the result there. So by now you should have understand like how the Boolean model works. So moving on, it's the conclusion. So before that, the few things that we should keep in mind is that Boolean model is one of the simple and effective model. It's easy to implement and reason about ideal for learning IF fundamental. So it is simple and effective, but it mostly not used nowadays. Only for simple tasks because the web pages and how the developers are encrypting, and it has become much advanced for this Boolean model. So unless and until we get ready-made documents or like that, it is useful. But if you want to scrap data directly from the internet and all, it doesn't perform well. And of course, it's foundational because it paved the way for modern information retrieval algorithms. It underpins the architecture of early search engines and modern structured queries. And as I told you, one of the major limitation is the key limitation. So there is no ranking of results. All matching documents are treated as equal and relevant, but still it's used still now for database queries, legal research tools, and structured retrieval systems. It's also one of the concepts taught in structured query languages or SQL and other related topics because it helps in data fetching and data output and all. So with this I will come to the end of this video. Hope you understand this Boolean logical model for information retrieval. Thank you.